welcome you all to session 2 of the chapter Linear Momentum. This session will be on center of mass. Then what actually is center of mass? Let us check it out. If I take a body, for example, if I take this scale, right? If I want to balance the scale, I need not to balance the whole scale. If I balance at a particular point on the scale has been balanced. Means every body has a point. At that point, if you balance, the whole body will be balanced. And that balancing point is called as center of mass. And every body has center of mass. So what is center of mass? Let us check it out. If I take a body, this is also a system of particles, because in this session we will be discussing center of mass of a system of particles. It is a body, it is made up of many particles. Let me call it a system of particles, right? So let me check it out. What is center of mass? It is a point on the body at which the whole body can be balanced. Means the entire mass of the body is supposed to be concentrated at that point. Right, so balancing whole body is nothing but balancing that balancing point now here, right? So at that point, the entire mass of the body is supposed to be concentrated, and that point is called as center of mass now here, right? Okay, why center? Because if it is a uniform body, the center of mass lies exactly at the center, right? But if it is a non-uniform body, then center of mass shift towards where actually the mass of the body is more now here, right? Okay, we will be learning much about that in the further sessions now here, right? Okay, now what is center of mass of a system of particles? Let us check it out. Let me define it first now here. Do you remember? Center of mass is a point. Okay, now let us check it out. What is center of mass of system of particles? Center of mass of a system of particles is defined as, see here, center of mass of a system of particles is defined as a point at which the entire mass of the body or entire mass of the system. Body is nothing but system of particles, right? Okay. Center of mass of a system of particles is defined as a point at which the entire mass of the system is supposed to be concentrated. Is supposed to be, what we say here? Concentrated. Is supposed to be concentrated. This is how center of mass is defined. Right? Okay, center of mass of a system of particles is defined as a point at which the entire mass of the system is supposed to be concentrated. Right? Okay, that is the name mass, because the entire mass of the system is supposed to be concentrated at that point, and that point is called as center of mass. Do you understand? Center of mass is a point, right, at which the entire mass of the body is supposed to be concentrated. Now, let us consider system of particles and let us find the equation for a center of mass now here, right? So this is the definition. Now let us check it out. If we are considering axis like this, let me consider this is x-axis, and let me consider this is the y-axis, and let me consider this is z-axis. Let me consider system of particles. So this is a body. Let me take like this. There are many particles here, right? Okay, let me take this particle whose mass is m1. Let me take like that. Okay, let me take another one particle here, this particle whose mass is m2, right? Let me take another one particle here whose mass is mn, because there are n number of particles. Let me consider there are n number of particles. So there are many particles here. Here also there is a particle, here. There are many particles. If I want to balance this system of particles, if I want to balance this body, there will be a point in the body at which entire mass is supposed to be concentrated. So what is that point? That point is called as center of mass, right? Okay, where actually this m1 particle is? So we know that we represent the position of a particle with a position vector. right? Okay, let me consider a position vector here. So this is m1, this is first position vector. Let me call it as r1 vector, right? What is position vector? It is a vector drawn from point of reference to that position, right? Okay, which is the second particle? Here is the second particle. Let me draw its position vector. So this is the position vector. So let me call it as r2 vector, right? Like this, there are many particles. This is let me call this is third particle, because let me consider there are many particles here. So let me take this is the third particle. Like this, there are n number of particles, and these are the position coordinates. Okay, now let us check it out. What actually happens here? Now let me write. Consider what we need to consider. Consider a system of particles. Consider a system of particles of. Okay. Consider a system of particles. How many particles? Let me consider. There are consider system of n particles. There are n particles in that system, right? Okay. Consider a particle of n system, n particles no here, right? Okay. Consider system of n particles of masses. What are the masses of the particles? m1, m2, m3 till what we shall take here mn, because there are n number of particles, right? Consider a system of n particles of masses m1, m2, m3 till mn. Where are they? With position vectors. I need to go with the position vectors. With position vectors. Which are the position vectors? r1 vector, r2 vector, r3 vector till rn vector, right? Consider system of n particles of masses m1, m2, m3 with position vectors r1, r2, r3 till rn. Okay, what is C? C is center of mass. Okay, let me write about this. Let C be center of mass of the system. Let C be center of mass of the system. And if C is center of mass of the system, let me draw its position here, right? Okay, let me tell its position also. This is called as position vector. Let me denote it by capital R vector. So to differentiate with other particles, let me take here capital R vector. This is position vector of what we say here, center of mass. So what is C? C, let's see. We know center of mass is a point. Let C be center of mass of the system, right? Then the position vector. Then the position vector of center of mass, then the position vector of center of mass is given by, let me take like this, is given by. The position vector of center of mass is given by. Okay, how to write the position vector? Let us check it out. That is r vector equal to. How to calculate the position vector? How it is defined here? Let us check it out. What is the mass of the first particle? m1, position vector r1, plus m2 position vector r2, plus dot dot till mn position vector rn, right? There are a number of particles. Let me take the product of mass and position vectors divided by m1 plus m2 dot dot till what we say here mn. This is how the position vector is defined, how the position vector of a center of mass can be calculated. So this is how the position of center of position vector of center of mass is given by r is equal to m1 r1 plus m2 or dot dot till mn divided by m1 plus m2 plus m dot dot what we say here plus mn. Okay, now if I am calculating about this, shall I write this as we have a long equation? Let me take a summation of that now here, right? Okay, let me consider like this, r vector equal to, right? Instead of writing like this, shall I write like this? Summation. Summation means addition, right? So mi ri vector. So let it like this, mi ri vector, where I begins from 1 to n, right? I starts from 1 to n, right? Summation of mi ri vector divided by summation if let me take here divided by, before that I starts from 1 to n. Okay, let me write summation of that also. Summation of, let me write general term. What is the general term? I, right? mi, where I begins from 1 to what we say here n. So this is how we represent the same equation, right? The same equation I represented in this way, right? Summation of mi ri vector I equal to 1 to n, summation of mi where I equal to 1 to n. Okay, this can be written as like this also, that is summation of I equal to 1 to n mi ri vector divided by, what is the meaning of the denominator? Summation of mi, summation of mass of all the particles of the system, right? If I calculate the mass of all the particles of the system, that itself is nothing but mass of the system, right? So what is the mass of the body? Mass of the body will be equal to mass of sum of the masses of all the particles in the body, right? Okay, sum of masses of all the particles of the body, let me write it as capital letter M. What is capital letter M denotes? Capital letter M means mass of the system here, right? So this is position vector of center of mass. So what is position vector of center of mass? R equal to summation of mi ri vector I equal to 1 to n divided by m. So what is m now here? Yeah, where m is what we say here, total mass. Let me call it as total mass of the, what we say here, system of the system, total mass of the system. Okay, so this is what we say here, position vector of center of mass. That is R equal to summation of mi ri vector I equal to 1 to n divided by capital letter M. What is capital letter M? It is nothing but sum of all the particles of the system, right? That is total mass of the system, and this gives position vector of center of mass. Now let me calculate what is the position coordinates of center of mass. Okay, how to calculate? Let us check it out. Now, after we came to know what is the position vector of center of mass, let us calculate what is the position coordinates. What are the coordinates of the, what we say here, center of mass? Okay. After knowing what is center of mass, let us understand what is the position coordinates of center of mass. So what are the coordinates of the center of mass, right? This coordinates I can write like this. What are the coordinates of center of mass? X, y, z. Let me take like this, right? Okay, let me write about this. What is that? Let x, y, z, capital letter x, y, z. Let me take, right? That is the position coordinates where actually the center of mass is, right? Let x, y, z be what we say here, position vector. Sorry, it is not a position vector, right? Let x, y, z be position coordinates. Position coordinates of what we say here, center of mass. Position coordinates of center of mass. Okay, what are the position coordinates of C? X, Y, Z. Right, you know, if it is x, y, z, it means x along x direction, y along y direction, z is along z direction. How to write it mathematically? How to write vectorally? Let us check it out, right? Okay, if this is the position coordinates of center of mass, then shall I write like this? This itself you can write in terms of equations now here. How to write it? Let us check it out. R vector equal to, what is the position vector what is the position coordinates? X, y, z. X along x-axis, let me write it as I cap. You know, I cap is a unit vector along x-axis, right? Plus, what shall I take now here? Y. Shall I take now here? J cap. What is the meaning of J cap? This is a unit along y-axis, right? Plus, what shall I write? Z k cap. What is k cap? That is unit vector along z-axis. So R vector in terms of position coordinates, I can write like this. X, y, z. This only in terms of vectorally, I can write like this also, right? Where? What is x? Let us check it out. What is x? It is nothing but along x-axis. You can take along x-axis. Let me take like this. M1, x1. Shall I say like this? M1, x1 plus along x-axis itself I am considering M2, x2. This is the position vector now here, right? So now I am speaking about the position along x-axis, y-axis, z-axis separately I am considering now, right? So M1, x1 plus M2, x2 plus dot plus what we say now here? Mn, what we say? Xn divided by, what do we get now here? M1 plus M2 plus dot. What do we get now here? Mn. Right, this can be written as, you know how to write this, that is summation of, generally mi ri, where r begins from 1 to n, whole divided by total mass of the system. Shall I take like this? So this is the x coordinates. So we are calculating what is the position coordinates of center of mass. I got what we say here, x. Now, in the similar manner, let me calculate y also, right? So, let us calculate y and z here. That gives position coordinates of center of mass. Okay, this is about x. Let me similarly calculate what is y equal to. So, what is y? m1 y1 plus m2 y2 plus dot dot plus mn, what shall I say now here? Yn divided by sum of masses divided by m1 plus m2 plus dot dot, what we say here? Mn. Okay, this can be written as summation of generally mi yi I equal to 1 to n divided by capital letter M. So what is capital letter M? It is the mass of the system, total mass of the system, right? So this is about y coordinate. Let me calculate about z coordinates. So what is that now here? m1 z1 plus m2 z2 plus dot dot plus mn zn whole divided by m1 plus m2 plus what we say here? Mn. Okay, this can be written as summation of mi zi, right? I equal to 1 to n whole divided by, what do you get here? Mass. So these are what we say here, position coordinates of center of mass, right? So let x, y, z be position coordinates of center of mass. This can be written in terms of vector, right? Position vector. So what are x, y, z? So we calculated. So these x, y, z are position coordinates of center of mass, right? In the next concept, we will be learning the motion of center of mass, right? If a body moves, right, how does the center of mass moves now here, right? So in the next concept, we will be learning about motion of center of mass. Now let us move on to the motion of the center of mass. Means if a system of particles moves, then center of mass also will move. Then we will be calculating what is its velocity and acceleration, right? In this session, we will be deriving the expression for velocity and acceleration, right? So this is a derivation, right? We will be obtaining an expression for velocity and acceleration of what? Center of mass of system of particles. We will be considering system of particles, and let us check it out what is its velocity and acceleration, right? Okay, let me derive this. Let me begin with the derivation. Right. So derivation of expression for velocity and acceleration of the center of mass of system of particles. Okay. Now let us take first system of particles. We know. Let me consider this is x, and let me consider this is y axis, and let me consider this is as a z axis. Right. As usual, let me consider system of particles. So this is a system of particles here. Right. Okay. Let me take this is the mass m1 of the first particle, and what is its position coordinate? Let me take position vector. This is r1 vector. Let me take like this, right? Okay, let me consider this is m2, mass of the second particle, and its position vector is r2. Let me consider like this, its position vector is r2 now here, right? Okay, this is the position vector. What is its position vector? r2. Let me consider another one particle whose mass is m3 and its position vector is r3. Let me consider like this, right? Okay, let me begin with the derivation. Consider a system of particles, a system of what we say here, n particles. How many particles are there in the system? N particles. Consider a system of n particles of what we say here, masses. What are the masses of the particles? m1, m2, m3 dot dot till what we say here, mn. Right? Okay. Where are they? With position vectors. With position vectors r1, r2, r3 dot dot what we say here, rn. So these are the position vectors of n particles. And let C be the center of mass of the system. Right? Okay. Let me write about this. Let C be. What is C? It is a point where entire mass is supposed to be concentrated. That is why let me take here. Let C be center of mass of the system. Center of mass of the system. Right? Okay. And its position coordinate, sorry, its position vector. Let me take like this. So this is the position vector. So what is the position vector? Capital letter R. Right? let C be center of mass of the system, right? Then the position vector of center of mass, we know that position vector of center of mass. How to calculate that? The position vector of center of mass, position vector of center of mass is given by, right? What is the position vector of center of mass? That is r vector. How to calculate? m1 r1 vector plus m2 r2 vector plus mn rn vector, right? So whole divided by, what do you get now here? Whole divided by m1 plus m2 plus dot till what we saying mn, right? This is how the position vector of center of mass is given, that we have already studied down here, right? Now let me write like this. This can be written as m1 r1 plus m2 r2 plus dot plus mn rn. The sum of all the particles of the system gives total mass of the system itself. So what is the total mass of the system? Let me take it as capital letter M, right? Okay, now what I will be doing, let me bring M to this side, right? So what do you get? M r vector is equal to m1 r1 vector plus m2 r2 vector plus dot plus mn rn vector. Okay, why did I do it like this? Let us check it out. Do remember, first of all, let me find what is its velocity. We know what is the velocity. V equal to, we know it is nothing but dx divided by dt. If you know the position, right? If you know the distance, so what is meant by velocity? It is a rate of change of displacement, right? Okay, that is a dx divided by dt, right? Similarly, we know what is the position vector. If you differentiate it, you get what we say here, velocity. Simple, right? If you know the position vector, differentiate it, you get velocity. Again, if you differentiate velocity, what do you get? Acceleration. Because what is acceleration? It is a rate of change of velocity, right? Do remember, simple derivation it is, right? We got the position vector, differentiate with respect to time, you get velocity. Again, you differentiate with respect to time, you get acceleration, and that is the end of the derivation, right? Simple derivation. Do remember this, right? Okay. So if I am calculating this, if I get this, let me go with the differentiating, right? Differentiating with respect to what we say now here, time t. Differentiate with respect to time t. Okay, so this mass will not change. dr divided by dt. Shall I take like this? That is equal to m1 differentiation of r dr1 divided by dt, right? Again plus m2 dr2 divided by dt, right? Okay, plus dot plus mn drn divided by dt. Differentiating here, right? Okay, we know that. Let me continue with the derivation here. So what do you get? We must know here is m. What is dr1 divided by dt? Right, you know, differentiation of position vector. What does it give? It gives velocity. Velocity of the first particle. What is dr2 divided by dt? Velocity of the second particle. What is the drn divided by dt? That is velocity of the nth particle. What is this dr by dt? It is the velocity of the center of mass. That itself we are calculating, right? Okay. Shall I write like this? M velocity of center of mass. Shall I write it as capital letter V? Right? Okay. That is equal to, what do you get now here? m1. What is the dr1 divided by dt? v1 vector. Shall I take like this? Velocity, right? Okay. Plus, what do you get? m2 v2 vector, right? This is nothing but velocity. Plus dot plus mn vn vector, right? We want velocity, so let me take it as v is equal to m1 v1 vector plus m2 v2 vector plus dot plus mn v1 vector whole divided by, let me bring m to this side because you want velocity, right? So what do you get here? Velocity v equal to, what is this? Shall I write in terms of summation, right? Summation, right? Generally I will be writing. So how to write general? mi vi vector, where I starts from 1 and ends at n. right? So from 1 to n, shall I write like this? Whole divided by, so what is m? Mass of the system. So this is the expression for velocity of center of mass. Simple. The velocity of center of mass is given like this. Summation of mi vi vector from I starts from 1 to n whole divided by m, where m is the mass of the system, right? So what is v? That is velocity of center of mass. Okay, this is how we calculated expression for velocity. Next, what we need to calculate? Expression for acceleration. How to calculate? Differentiated, right? Okay, let me take this equation here, right? Let me take it as equation number 1. Instead of writing again, let me take that and differentiate now here, right? Okay, differentiating equation 1 with respect to time t. With respect to time t, you differentiate it. Okay, let me differentiate, right? Mass will not change. Shall I write like this? dv divided by dt, right? So that is equal to, what do you get here? m1 dv1 vector divided by dt, differentiating this equation, right? Plus m2 dv2 divided by dt, right? Plus dot dot plus mn, differentiate that, dv1 divided by what we say here, dt. We know that what is the acceleration, that is the rate of change of velocity. If you differentiate velocity, you will be getting what we say here, acceleration, right? So what is acceleration? You know what is acceleration? dv divided by dt, rate of change of velocity is acceleration, right? So this is acceleration. Come on, tell me now here. What is dv1 divided by dt? It is nothing but acceleration of the first particle, right? a1, that is acceleration of the first particle. What is dv2 divided by dt? Acceleration of the second particle. What is dvn divided by dt? Acceleration of the nth particle, right? Then what is dv by dt? Acceleration of center of mass. That itself we want, right? Okay, now let me write that. So what do you get? m, acceleration of center of mass. So let me take it as a, general a vector, that is equal to, what do you get? m1 a1 vector. Shall I take like this, right? Plus m2 a2 vector plus dot dot mn an vector, right? Now what is acceleration? What we are calculating? m1 a1 vector plus m2 a2 vector dot dot plus mn an vector whole divided by what we get now here, capital letter m, right? This can be written as like this, a vector equal to, similarly what I have written here. This generally you can write it as summation, general equation. What is that? mi ai vector, where I begins from 1 to n whole divided by mass of the system. What is this? This is acceleration. Whose acceleration? Acceleration of the center of mass, right? Center of mass of the system of particles. So we got velocity as well as what we got here, acceleration. So this is the end of the derivation, right? Derive the expressions for velocity and acceleration of center of mass of system of particles, and this is how we will be deriving it, right? It is a simple derivation. Whenever you get a position vector, differentiate it, you get velocity, you differentiate velocity, you get acceleration, right? This is how we will be deriving the expression for velocity as well as acceleration of center of mass of system of particles. Now let us take some note points. If no external force acts on the system, if there is no external force act on the system, what will be the velocity as well as acceleration? Let us check it out, right? Now let me first write about the velocity. You know, we have derived already the expression for velocity, vm into v vector. This can be written as like this, right? Summation of, what do we write? mi vi vector, where I starts from 1 to n. So this is the expression what we got now here, right? Now what will be this equal to? Come on, tell me, what is this? Mass into velocity. What is mass into velocity? It is nothing but momentum, right? We know what is momentum? Mass into velocity. What this is, sum of momentum of all the particles, right? mi pi, let me take mi pi is the momentum of the first particle. m1 p1 be the momentum of the first particle, m2 p2 be the momentum of the second particle. In the similar manner, mn pn be the momentum of the nth particle. If we add all the momentum of the particles, we get the momentum of the body itself. That is what it is, right? Directly, it is a summation of momentum of all the particles. Shall I write this instead of this? Shall I write now here P vector? So what is P? P is momentum of the system of particles, right? It is the momentum of the body itself, momentum of the total system of the particles. That is P, right? Okay, we know that. We have already studied law of conservation of momentum. What does law of conservation of momentum says? If no external force acts on a system, then momentum is conserved, right? Momentum of the system remains constant. That is what we derived in the last session, right? So we got momentum, and this momentum will be, what we say here, this momentum will be constant. When it will be constant? If external force to net external force is equal to 0. This is what law of conservation of momentum says. What does it say? If net external force acting on a system is 0, momentum remains constant. Momentum becomes what we say here, constant, right? So if momentum becomes constant, then what happens? Mass, it will not change. That implies the velocity will also be what we say here, constant, right? So do remember, this is nothing but momentum. Momentum is constant if external force acts on a system is 0 now here, right? If this is constant, right, m is, of course, it is mass of the body, it is constant here, v also becomes constant, right? Okay, let me write about this. If no external force acts on the system, if no external force acts on the system, okay, no external force acts on the system, then velocity of, what is this? Velocity of center of mass, velocity of center of mass remains what we say here, constant. Velocity of center of mass remains what we say here, constant. Do remember this, right? So if no external force acts on a system, if there is no external force acting on the system, the velocity of the center of mass remains constant. I am speaking about velocity. Velocity remains constant if no external force acts on the system. Means it is nothing but Newton's law, right? If no external force acts on the system, the body at rest will remain at rest itself, right? Body in uniform motion, constant velocity will remain in the constant motion itself, right? It is nothing but indication of Newton's law, right? If no external force acts on the system, then the velocity of center of mass remains constant. Let us check it out. What about the acceleration, right? Second one. Okay, acceleration, we know how we got now here, that is A vector is equal to summation of mi ai vector, where I begins from 1 to n, right? Okay, now do you understand what is this mass and acceleration? Okay, what actually the product of mass and acceleration gives? Nothing but force, right? Okay, this is nothing but sum of forces which act on all the particles, right? The force on first particle, it can be written as m1 a1 vector. Force on the second particle, m2 a2 vector. Force on the nth particle, m1 an vector. If we add that, it is nothing but total net force act on the system, right? It is nothing but force. Do remember, mass into acceleration. Here mass into velocity, it was nothing but what? Momentum there. Here mass into acceleration is nothing but what now here? Total force acting on the system now here, right? What happens to total force? We know that total force acting on a system, that will be equal to what we say here? 0, right? Why? If net external force acting on a system is 0, right? If there are no external force acting on a system, then the force on the system will be equal to 0, right? So if no force acts on the system, the force on the what we say center of mass, that also will be equal to what we say here, 0, right? So mass cannot be equal to 0. That implies acceleration will be what we say here, 0, right? So do remember, m a vector equal to 0. Mass cannot be equal to 0. Acceleration must be equal to 0, right? What does it say? Whatever, do remember, velocity is constant, acceleration is 0, right? Okay, let me write the same thing. If no external force acts on the system, if no external force acts on the system, if no external force acts on the system, then I'm speaking about acceleration. Acceleration of, whose acceleration? Center of mass. Acceleration of center of mass is, what is the acceleration of center of mass? Is 0, right? Do remember, if no external force acts on the system, acceleration remains 0, right? That is, if force equal to 0, acceleration is also equal to 0, right? Simple. Let me conclude this session by these 2 points, right? If no external force acts on a system, velocity of a center of mass remains constant. If no external force acts on the system, acceleration of center of mass is equal to 0, right? This was all about center of mass of system of particles. Thank you.